Here is one of the top 5 most attended presentations in 2020 at Horizon, a user conference dedicated to IBM Planning Analytics and TM1. There's no surprise that this topic made it to the top watched presentations from Horizon, a conference dedicated to IBM Planning Analytics and TM1. Here is Data Science 101 for finance teams with Nicholas Renotte.
Okay, all right, it's 3 o'clock. We're on. We've got Nick Renotte up next here from IBM. Thank you, Nick, for your time. Nick is an expert on data science, twinning that with TM1. But this session is a 101 for finance folks. And yeah, take it away, Nick. Nick's got great energy, and I hope it all rubs off on you.
Perfect, thank you. Well, hello everyone. My name is Nicholas Renotte, and I'm presenting to you live from Sydney, Australia. So as Jason said, today we're going to be taking a look at Data Science 101 for finance teams. So let's take a little bit of a deeper look as to what we're going to be going through today. So ideally, what I want you to take out of this session is 3 key things. So ideally, I want to give you a bit of an overview as to the ultimate data science framework that you need to enable data science to work effectively within your business. And then we're going to demystify a little bit of the jargon that surrounds machine learning, AI, deep learning, and all of that good stuff. So everything that's floating around today, there's a lot of jargon around it. So we're going to try to demystify that and unbox that a little bit for our finance teams. And last but not least, we're going to be taking a look at some low-hanging AI fruit for finance. Now, you're probably thinking, Nick, what the hell are you talking about, AI fruit? Well, we're going to look at some practical use cases that you can take away to get started with AI and machine learning in your business. Now, before I kick things off too much, I'm going to be live and interacting within the chat. So if you've got any questions at all, by all means, make sure you drop a mention in those and we'll answer them live. Or if you've got any questions, I'll leave my contact details at the end. So without further ado, let's kick this off and let's take a look at some data science frameworks. Perfect. Now, I want to start off our data science frameworks with a little bit of a story. So our story begins with Barry. So Barry right now is driving an ambulance. Now you're probably thinking, where on earth is this leading? Well, Barry had a bit of an accident and he's actually driving himself to a medical emergency department. Now you're probably thinking, where is this going? Well, there's a very good reason why I'm starting off our session by telling you the story of Barry. And that's because Barry driving himself to the medical emergency department is actually the acronym for the baseline data science framework that underpins a whole heap of data science projects around the world. Now, let's take a look at what this actually means. So if we take a look at this initialism, so Barry drove directly to the nearest medical emergency department, it actually stands for the 6 key steps that underpin virtually every good data science project that is running around these days. So these 6 steps stand for business understanding, data preparation, modeling, evaluation, and deployment. Now, let's take this and put it into a little bit of context. So every data science project starts off with business understanding. So I think you'd agree with me that whenever you're embarking on a new endeavor, you want to understand the context that you're operating in. So this is where business understanding comes in. Before starting any data science project, you really want to understand the business environment and the things that are impacting your business in order to encapsulate those within your project. So this is where our business understanding comes in. Arguably, in my personal opinion, business understanding is probably one of the most important, if not the most important step in the data science lifecycle. Now, our next step, whenever we're getting started with data science projects, is data understanding. This is where we begin to understand what data we've actually got available. What is the quality looking like? How good is it? Is it terrible? Do we need to make adjustments to it? How much data do we have? Where was this data collected? So say, for example, we're working with some general ledger data. Well, this is where we'd start to take a look and see, hey, is there data that's been miscoded to the wrong account or the wrong cost center? Is there incorrect descriptions? Do we have terrible commentary or do we have mismatching journal line items? This is where we really start to understand the data that we've actually got available. Now, this brings us to our next step, data preparation. whenever we're going to go and build a machine learning model or build a deep learning model or perform natural language processing, we want to get a handle on our data in order to prepare it for our modeling step. In our data preparation step, this is where we actually go ahead and fill in missing values, transform it, add additional information. So say, for example, we're going to produce a sales forecast, and we know, for example, that weather impacts our sales. In our data preparation step, we might take our weather data and combine it with our baseline GL data to produce a better sales forecast. So this is where we start to collaborate and work with other data sources. Now, once we've prepared our data, so keep in mind that once we've reached our data preparation step, we've already understood our data, we understand our business context. This is where we get to modeling. Now, modeling is probably one of those steps where you just need to get through it to see what your model looks like. But this is also where you choose what type of algorithms you use, what type of tasks you perform, and what your ideally what your outcomes are. So if you've prepared your data in one way, you might choose to use a specific set of algorithms. If you've prepared it another way, you might choose to use those algorithms. Now, you'll see here that this arrow is actually going both ways. That's because just because you've performed the modeling step doesn't mean you won't go back to the data preparation step, refine and remodel. So I think a practical aspect of data science is that it's an iterative process. It's not just a one and done style thing. So you might need to go through and update information, add additional information to ideally get to the right outcome. Now, once you've done a bunch of modeling, this is where we get to our evaluation step. And really, evaluation is a fancy term for just working out how well our model is performing. Is it achieving the right business outcomes? Is it performing accurately? Is it performing not so well in certain scenarios? This is where we try to work out where are the shortfalls within our model. Now, also, once we perform that evaluation step, we can either go one of two routes. We can go to deployment and take our model and deploy it live and push it into production. But again, the data science lifecycle is iterative. So even though we might have performed our evaluation, we can always go back to our business understanding step and reiterate and refresh our model to improve on it. So that really encapsulates the data science lifecycle. So what I want you to take away from that is Barry drove directly to the medical emergency department. So that's going to help you remember each one of those steps that forms the entire or the ultimate data science framework to get you started. Now, the next thing that we're going to take a look at is demystifying a little bit of the jargon that's floating around the industry at the moment. So we've got AI, we've got machine learning, we've got deep learning, we've also got data science. I think I forgot that one there. But there's a lot of information that's floating around there and a lot of jargon that's also floating around. So it's all going to begin with artificial intelligence. So artificial intelligence really has two key streams. So within AI, we have narrow AI, and we also have general or broad AI. So narrow AI is the application or teaching a computer to be able to do things without explicitly programming. So what I mean by that is that in normal processes, we'll give or we'll take some data, we'll apply some rules, and we'll get answers. This is what we call traditional programming, right? So we give it some logic and we're able to pass it through and get answers. When we use AI or narrow AI, where we pass an algorithm data plus historical answers, and it starts to learn those rules. This is also what we commonly refer to as machine learning, but we'll come to that in a second. Broad AI or general AI is the all-seeing, all-knowing AI. It's the ability for a computer to do really broad tasks without being explicitly programmed. So when we look at narrow AI, these are really specific use cases. For example, when we're forecasting sales, or when we're using computer vision to perceive a specific set of outcomes within an image. Likewise, when we look at broad AI, these are really broad things. So this might be able to, or might be the process of teaching a computer to recognize objects within images, but also speak at the same time. So ideally, it's giving human-like qualities to a computer. Now, at the moment, as it stands, the AI field is progressing quite rapidly, but we still are a little bit of a while away from progressing all the way through to broad AI. So we're getting there, but it's still going to take a little bit of time. Now, this brings us to our next step, machine learning. So machine learning is a subset of artificial intelligence, and it has three key aspects to it, or three key streams within machine learning. So the streams that you'll normally hear referred to in machine learning are supervised machine learning, unsupervised machine learning, And now there's a new field coming about, which is called semi-supervised machine learning. So semi-supervised machine learning is also referred to as reinforcement learning. So it's a newer field that is now rapidly evolving. When we talk about supervised machine learning, this is where we're training algorithms to do one of two things, either classification or regression. So regression is where we're predicting a number. For example, if we're producing a sales forecasting machine learning model, this would normally fall into the realm of machine learning regression. Likewise, we might also choose to produce a model that performs classification. So say we wanted to determine which of our customers were going to churn. Well, that is actually a form of machine learning, still machine learning, but now it's called classification. We can also step away from our supervised learning step, which consists of regression and classification, and take a look at unsupervised machine learning. This is where we look at things like clustering and anomaly detection. Now, the last aspect of machine learning is reinforcement learning. So reinforcement learning is a new and rapidly evolving field, and it's really all to do with taking an algorithm and letting it train live within an active environment. So where you see reinforcement learning being used quite a fair bit is within gaming and within IoT. So we take sensors and we measure what our impacts of adjustments are in order to produce a reward. Based on how much of a reward is being attributed to our reinforcement learning algorithm, we're able to improve or not improve a specific outcome. Now, the last aspect that we wanted to take a look at, or second last, is deep learning. So deep learning is a subset of machine learning, and it's really the exact same thing. So where we're taking a look at classification, regression, clustering, and unsupervised learning and reinforcement learning, these can all be performed by deep learning. Where deep learning differs is that it's the application of a specific set of algorithms. So within machine learning, there's a heap of algorithms out there. There's random forest algorithms, there's gradient boosting algorithms. Deep learning allows you to perform those same tasks, so sales forecasting, churn prediction. The only difference is that it's using deep neural networks. So whenever you see those diagrams drawn where you've got a lot of little neurons, that's normally what people are referring to when they're talking about deep learning. Now you're probably thinking, all right, Nick, you've given us AI, you've given us machine learning, you've given us deep learning. Where does data science fit in this big wild world? Well, data science forms an overlap between AI, machine learning, and deep learning. So data science is really the practice of applying AI, machine learning, and deep learning. And it's really broader than just the specific algorithms. That's why I sort of focus on that framework to begin with, because that sort of gives you an idea of all the things that fall within data science. So remember, Barry drove directly to the medical emergency department. Each one of those steps is still part of data science. AI, machine learning, and deep learning are really niche parts of our modeling and data preparation and data understanding steps. So that really encapsulates AI versus machine learning versus deep learning and versus data science. Now what we're going to take a look at is our low-hanging fruit. So I promised at the start of this that we'd take a look at some really practical use cases that you can take to start using with your TM1 or planning analytics model. Now, the first one that we want to take a look at is forecasting sales with Facebook profit. I should also point out that these practical use cases that I'm showing here, in about an hour's time, we're actually going to be demonstrating them live. So at 5 o'clock, we'll actually see these live. So the first application is forecasting sales with Facebook profit. So using TM1 Pi, the amazing library produced by the CubeWise code team, you're able to open up your TM1 model and start doing a lot more or significantly more advanced stuff with your TM1 model. One of those applications is using Facebook profit to build and generate time series forecasts within your machine learning model. This allows you to forecast a whole heap faster at month end. So say, for example, you're producing a forecast at month end, or you're producing a forecast at quarter end, or at half year, or at year end. Allowing you, or using Facebook profit, you're able to do this a whole lot faster. So rather than waiting for those specific intervals, you could produce a new forecast or a new sales forecast every day, because it's just an algorithm that's been trained on your historical data to go and forecast forward. So this gives you a whole lot more power and a whole lot more flexibility to start generating things and start producing efficiencies within your team a whole lot faster. The next use case that we're going to take a look at is how we can analyze account correlation with pandas. So pandas is a really, really powerful Python library that allows you, that's pretty much the baseline for data science today. So virtually every data science project is either going to use one of two libraries, either Pandas or NumPy. Pandas has a slight advantage over NumPy. I mean, ultimately, they have slightly different use cases, but they're all to do with manipulating data. It does have a slight advantage in that it has a lot of built-in data and analysis libraries. So say, for example, you wanted to produce a correlation plot. Literally using a single line of code, so df.core, you're able to produce a correlation plot and analyze the differences or the relationships between your different accounts within your TM1 models. This allows you to get a better understanding as to what might be driving certain outcomes within specific models. You can also perform a whole heap of additional types of data analysis. Say you wanted to generate summary statistics like mean, min, max, mode, and look at your different quartiles. Literally using the df.describe method, you're able to do that as well. So really quickly, you're able to get up and running and start to dig a little deeper as to what is driving certain accounts within your models. Now, the next use case that we're going to take a look at is how we can optimize cash flow. So Cplex is a really powerful library or algorithm that allows you to perform linear programming and solve optimization problems within your TM1 model. So there's a whole bunch of APIs that sit within Cplex, specifically the DocPlex library, that allow you to perform optimization models. So this is going to be one of the use cases that we take a look at a little bit later, but it allows you to perform a whole bunch of optimizations. So say, for example, you've got one of those problems where you've got a constrained problem and you're trying to work out, hey, what's the optimal number to allocate to this particular project or to that particular project? This is where Cplex can come in alongside TM1Py, and you can start to automate these solver processes. So that allows you to generate optimal solutions a whole lot faster. So there's less guesswork and entering in specific numbers or random numbers to try to work out a specific outcome. You can do it a whole lot faster with a click of a button. And the beautiful thing about it is that your data never leaves your TM1 model. It's sent in transit using TM1Py. You're able to generate that specific outcome and bring it back into your TM1 model, all with the click of a TI or action button. All right, so that really covers optimization with cash flow or optimizing cash flow with Cplex and Python. The next use case that we wanted to take a look at, or our next low-hanging fruit use case, is how we can capture commentary with Watson Assistant. So this is one of the newer things that I've been working on, and it starts to show the additional capabilities or additional ways to start working with your TM1 model. So say, for example, you have a bit of a workflow, for example, for how you collect your commentary within your business. So normally you'd go through, you'd scan your different accounts, you'd work out what accounts require commentary, which ones don't. And more often than not, you'd get commentary which is a little bit haphazard or doesn't really address a specific outcome. Well, Watson Assistant allows you to answer commentary and push that data directly back into your TM1 model using serverless functions. So these are a relatively new innovation within cloud computing, and it basically means that you can push data into your TM1 model from literally anywhere. With one API call, we can now send data from anywhere. And the beautiful thing about that is that we can start to use natural language processing and tools like Watson Assistant to capture commentary a whole lot faster. So that's our fourth use case. Our fifth and final use case is classifying customers and categories with scikit-learn. So I think we talked a little bit earlier on about Facebook Profit and how Facebook Profit allows us to produce time series forecasts to produce faster sales forecasts. Well, Facebook Profit is a library that gives us a specific set of algorithms. Scikit-learn is another library similar to Facebook Profit, but it gives you a whole heap of additional data science algorithms. So specifically, one of the algorithms that it gives you is random forest classification. So using the random forest classification algorithm, you're actually able to generate classification models. Now, a great application of classification models is working out which of your customers are likely to churn and which of those aren't likely to churn. So you can actually now start to forecast churn within your business models simply with a click of a button and push those results into TM1Py. So to quickly summarize, we've gone through a bunch of use cases there. We took a look at Facebook Profit, account correlation. We also saw what we can do with Pandas and Watson Assistant. Now, that about wraps up all of the use cases that we had for you. If you want to see some more TM1 goodness, I'm going to plug myself a little bit. There's a whole bunch of great videos on my YouTube channel, And if you'd like to get into contact with me, by all means, my email is now on the screen. Thank you everyone for attending. Oh, and if you've got any questions, by all means, please reach out in the chat. I'm more than happy to answer any questions.
Thanks, Jason here. Nick, thanks for that. I think you just broke the world record for a number of words per minute over an extended period. You probably need an oxygen mask for the next few minutes. So yeah, okay, so let's get some questions through here. Max Parsons. We have our expertise in our organization. When he says R, he means the big R, yeah? Is this new capability, TM1 Pi, etc., what you're talking about, is that similar to TM1 capability?
Yeah, so what I've actually done, and that's a really great question that you've got there. So this is why in the data science lifecycle, we're taking a look at the couple of key steps. So we had business understanding, data prep, so on and so forth. But deployment is where we then go and deploy a specific model via REST API. This literally means that you can now hit it with any algorithm. So in the session, or in the session in a couple of hours time, I'm going to show how we can use Watson Assistant with TM1. Now, because that model is actually, or the specific model that talks to TM1 is deployed as a serverless function, you can hit it with any language. So if you wanted to use it with JavaScript, or if you wanted to make a request with R, you could definitely do that as well. So it really starts to open up a whole heap of capability regardless of what language you use.
Great. Okay. We've got another question. Stefan Leone says, any real life applications with IBM Planning Analytics? So data science projects. I guess you go through that a bit later, but I mean, are these like real projects, or are these more a proof of concept, I guess is what people probably want to know.
Yeah, so I mean, everything that I've shown is they're based on real projects that the clients are now using. So there a number of clients are actually doing the sales forecasting, but as part of getting to that sales forecasting, you need to be able to perform that analytics. So that's where that correlation step comes in. The Watson Assistant one is really, really new. So I only finished developing that maybe 2 or 3 weeks ago. So you guys are probably going to be some of the first to see it. But a lot of users are now starting to use TM1 Pi quite actively in a lot of their projects. So I think a lot of them are actually at TM1 or at capitalise Horizon right now.
Okay. We've got another question from Ankur. Have you done much with Matplotlib? Maybe you should just say what it is first.
Yeah, you got it.
Jupyter Notebooks, etc., sort of thing.
Yeah. So Matplotlib is a visualization library. So so because you can grab data, there's actually a blog post that I think I wrote, and Jason, you might have had some input into it. But we actually showed how you can visualize data from Planning Analytics using Matplotlib, and I think we extended it further and took a look at what you can do with Plotly and Seaborn as well. But yeah, you can definitely do work with Matplotlib. Again, remember with TM1 Pi, you can extract anything you want out of your TM1 cubes, and because you've now got the data inside of Python, you can use any standard Python library. So if you wanted to use TensorFlow, PyTorch, Theano, Matplotlib, Seaborn, Plotly, all of those are now available.
Yeah. Okay. So I mean, just on that sort of that serverless thing, is you see that's the way things are going. You think for TM1 users, they can use TM1 Pi to pull from TM1, put it up to a service, bring it back in.
Yeah. So I mean, in that, I think this is why I started working on that Watson Assistant use case, because Watson Assistant is a tool, but I think the cooler thing is that if you can deploy TM1 Pi as a serverless function, which you definitely can, so I'll show that, you can now hook it into anything. So if you wanted to work with it in JavaScript, or if you wanted to work with it in Scala, or like one of these new languages that are coming out, you can now start to do that. So there's a whole heap that you can start doing with that as well. I think that's going to be really interesting going forward. So ideally where I want to get to with that NLP style capability is that you can have a user open up a virtual assistant on their phone and go, hey, I want to update my budget to 300,000 and spread it evenly across the next 12 months. And your assistant just goes ahead and does that using the serverless function and using TM1 Pi. But it really starts to open up TM1 that way.
Yeah. Good stuff. Okay. All right. I think we better put an end to it there, Nick, so that you can recover. I think we all need to recover as well. And in the chat, there's been an outpouring of love for you, man. That's yeah, as usual. Great stuff. Okay, I'm going to